and this is about packets and data transmission. So this is actually something that I used to use when I used to teach networking on the A-level course. But anyway, the thing about any message you want to set over the network is that what we do is we take the message itself and we break it up into packets. These things called packets, and they're just basically chunks. So you might take I don't know. There's the network protocol that you're using will define how big the packets should be. So it'll tell you exactly what's going to go in each packet. But basically, you take your message and you chop it up into pieces called packets. And then what we do is within the packet, this isn't quite, it's a little bit misleading, the terminology here. At the front of it, we put a header. And as it says here, it's got the to and the from address. It's got the packet sequence number. And it's needed so the network can correctly send the packet to the right place. We've then got rather than saying message, it would be better to say data. So if you imagine you take your email message and you chop it up into pieces, each piece will go into a separate packet, and that would be in that middle part there, the data. So that's the it says here message content. It can be any form of data. It's just binary data, so it could be represent a piece of text. It could represent an image, a sound. It can be even a program. And then at the back end of the packet, you've got this thing called the footer, and that usually is error checking stuff. We might include a thing called a checksum. So a checksum is a number that's calculated using the data. So the idea is you take the packet, you do a little bit of maths on the data, and that produces a number. You then send that number with the packet, and then when it gets to the other end, what we can do is we can take the data, calculate what the number should be, and compare it to the one we've got. And if they don't match, we know we've got an error and we need to retransmit the packet. And that's one of the reasons why in the front of the message we have, as it says here, the packet sequence number. So what you can do is you can send a message to the sender saying, I need you to retransmit packet number 4, please, because it's corrupted. So what we then do is we take our map packets and we stick them on the network, and we've got two possibilities here. So we can do, first thing we're going to do when we set up our link is we have to do a thing called handshaking, and that's where the two ends of the communication link will start negotiating how it's going to communicate. And they'll agree specific details. For example, if you've got a wireless system, one of the things that the two devices have got to agree is which radio frequencies they're going to use. And you've got various different examples I'll put down there. So we can either send the data over a network using circuit switching or packet switching. Circuit switching is the easiest to understand because basically what you do is you send all the data down a single link. So in this case, we've got the machine on the left. That all of the data that goes to the machine on the right is going to take exactly the same route on the communication network. Now, this is problematic because what happens, as it says here, you create a virtual circuit between point A and point B, but that circuit is now busy for the entire duration of the transmission. So if one device sends and then it waits for a response, the circuit is busy while it's waiting for the response if the other end's busy. The other kind of thing is that when you send the packets, they're going to arrive in the order they were sent in, so you don't have to kind of reorder them. But it's relatively easy to intercept packets on the way, so you can do what's known as a man-in-the-middle attack. Sit on the circuit and watch the packets go by, and you see the whole of the message. So security-wise, it's pretty bad. It's also bad from a resilience point of view, because if the circuit fails, then you lose all your data. So we also have, and it says here, we also have packet switching. And packet switching is, I should say there, packet switching is commonly used for computer networks to overcome many of the problems associated with circuit switching. This is kind of like, if you like, this is pretty much what people tend to do. It's what's known as a de facto standard. It's not a requirement that it's done this way, but this is what most people tend to do. So what we do is we have all of our nodes connected on a network, and when you want to transmit data, you simply put your packets on the network, and the network then lets routes each packet, and they'll probably each take a different route to its destination. The routes are determined by the routers on the network, and what they'll do is if a circuit's busy or it's failed or something like that, it will route around the problem. So what this does is it's a bit like saying to everyone, we're in one part of school, I want everyone to go to another part of school, and just let people choose their own route. Some people will take a direct route, some people will take a kind of roundabout route, but one thing that will happen is you won't arrive in the order that you left. So the packets, over a packet switch network, don't arrive in order, so we have to resequence them when they get to their destination. And we may need to request some, because some packets may have gone and taken a kind of really elaborate route and actually, take ages to get their destination. When you request a web page in America, there's a chance that some of the packets may route around the world using one route, and some of them may head off in the completely opposite direction. It's unlikely, but it might happen. So you might end up with part of your message missing, and you have to request that one again. Now, pros and cons: packet switching, take different routes, single routes for circuit. Packets will use, the links become only busy for relatively short amounts of time. So that lets us better use our network, whereas circuit switching, the links are busy all the time. Packet switching, we need to reorder. Circuit switching, we don't. Packet switching is more secure just inherently, because you can't sit on a link and watch all of the communication unless it's the one that connects your computer to the ISP. If you sat on that link, the telephone circuit coming out of your house, then you could watch the whole of the message. But if you're on any other part of the network, you won't be able to. And circuit switching is easier to intercept. Packet switching spreads the load over the network. Circuit switching takes one node. So if this is a little animation, so if we kind of watch this, you'll see that what happens is we've got someone who's typing in there. They make a picture of a flower and they send it, and it gets broken up into pieces, and then it goes down the network, and it then heads into the ISP, and then it just routes around the network and takes random routes, or what look like random routes, and eventually all of the packets will arrive at their destination. When they do get to the destination, what's going to happen is on receipt, the receiver's going to have to put those pieces of data back into the correct order to create the picture. So now, as you can see, we just have to kind of resequence stuff and we get our picture back. So we have protocols, and we're going to have a look at those now. Now, this is where we want to go from. We're going to have a look at, we'll just have a quick look at this. So I've got a web page here. I type in an address, and what happens is I type in a URL, a uniform resource locator, into my web browser. The URL is taken away and it's passed to a thing called a DNS, a domain name services server, and that takes the high-level domain, which in this case is en.wikipedia.org, and it says who is that, and it comes up with a number, and that number is the IP address, the Internet Protocol address. This is the old format of IP I've shown you here. Once we've done that, what we then do is we then send an HTTP request, a Hypertext Transfer Protocol request, to that IP address. What then happens is the web server running on that machine gets the request, and it identifies the files that we need, and that comes from the latter part of the URL. And it then transmits. And when we're transmitting data between the two nodes, what's happening is we're using Internet Protocol to deliver the packets, and we use this single transmission connect protocol to make sure we can reliably move the packet from point A to point B. I'll explain what this means in a little bit, hopefully a little bit more clearly shortly. And what then happens is when our web server's got it's worked out which file it needs, because it's just a data file. So what it then does is it takes that file and it will then transfer the file from the web server back to the client that asked for it using this thing called FTP, which is File Transfer Protocol. So there's my file. That's what a web page looks like, and that was what the web page looked like that I wanted to look at. So it's picked up the file, it's read the links in here, the embedded links, and it's identified other files that file is dependent on, and then it will simply blast each of those files through the network using FTP. And they get sent back to our user. And then when the user gets the web page, it receives it, and then it kind of just basically reads the data and it renders the page, and we get to see the web page. So there's actually quite a bit going on. When you're sending an email, you're using lots of different protocols as well. We use things called SMTP, Simple Mail Transfer Protocol, that sends and receives messages. We use IMAP, which is Internet Message Access Protocol. So if your mail server's online, we'll use IMAP to talk to it. So if you're using like Outlook within Microsoft Outlook to get to your mail, that's using IMAP to get the messages, and then to send them it's using SMTP. And then you've got this thing called POP, Post Office Protocol, and that's the thing that's used in transferring emails from, like, you've got you have a sending post office, and there's a receiving post office, and POP transfers the files. So even if you're not online, the post office can receive your emails, and then when you next log in, your web client will use IMAP to talk to the post office and download your messages, so you see new messages. So what we're going to do is we're going to look at kind of some specific stuff. My apologies for that big loud sound there. That was rather unnecessary. So we've got this little presentation you're going to look at here, and I'm kind of hoping that you can see that. Can you just can you see that on the screen, guys? Can you see protocols? Can you just stick a message in the chat and let me know?
Oh, sorry.
Can you see that? Right, you can't.
Oh, I can now.
Okay, good. Right. Okay. So we've got protocols. We're going to look at some of that. So a protocol is a set of rules that govern communication between two or more devices. And it's simply, as it says there, it dictates the way in which the devices talk to one another. And what happens, we have packets, that's a small bundle of data over a network, and we've got various bits of data within there, as it says. We take the message, break it up, and then we package it up with a header, and we add all this control information: source, destination, sequence, number, and the checksums. And then we send them from one router to another, and the routers make decisions about which route the data should take. And it may route down different take different routes. And if a route goes down, it will ultimately route around it. And then the protocols we need to know about. First of all, we've got Ethernet. Ethernet is what we've got in school. Our local area network in school is an Ethernet. So it's a system for connecting computer systems on a network, and it runs a series of protocols to make it happen. And there's, for example, one protocol that makes sure that two devices don't send down the same line at the same time, and because that creates collisions, and there's mechanisms in place. There's a thing called CSMACD that is used to deal with those collisions. And what happens is before we send, we basically wait for the route to become free. And if two devices do send at the same time, then they kind of both wait a random amount of time before they retransmit. And they do a thing called exponential back off to make sure that if they do get a collision, we avoid that. Wi-Fi or Wi-Fi, notice it's a trademark. Wi-Fi is what stands for, as it says there, wireless hi-fi, and it is a trademark name. So Wi-Fi, what we refer to as it's wireless internet, and it's lots of different protocols that we use. And when two devices are going to communicate, they've got to decide which one they're going to use. And as it says here, you've got 600 gigahertz protocols, good for streaming video. So we then have these things called MAC addresses, and there's an example of one at the bottom of the screen there. And this is a 12-digit hex number that's built into every network hardware device, and it's actually put in at manufacture, so you can't change it. And it identifies the device on the network. So even if you haven't configured two computers, they have a network address and they can talk to each other if you know how. So if you're running a big data center, you can use this stuff. You can use mechanisms to kind of talk to a machine even before you've given it its standard network address, the IP address. And you can't change the incidentally, you can't change MAC address. So if, for example, when hackers attack a system, most of the access is done via IP, but you can identify the MAC address, and therefore you can identify the device doing the attack, which is one of the reasons you can never really hide your identity. You can't hide your identity anywhere. Anyway, then we've got this thing called TCP, Transmission Control Protocol. And as it says there, it's the thing that establishes the links. So when two devices start talking, TCP is the thing that kind of gets the two nodes talking to each other. And as it says there, it's all about connections. So it's a really fundamental protocol, and it determines how to break up the packets of data, how to put them back together when they arrive. And TCP is used is kind of lots of other protocols. We say they run on top of TCP, so they really rely on TCP as a kind of an underlying part of it. Then we've got this thing called UDP, Universal User Datagram Protocol. That's I think, well, the way I think about TCP is TCP has error checking in, so it sends and then it makes sure that the sender got the message okay. TCP is a bit like kind of someone just yelling in the street. They're not interested in whether you got the message, they just blast it out. So as it says here, it doesn't guarantee error-free transport of packets. Some packets can be lost. It just blasts it out and doesn't really care what happens. So as it says here, very good for retrieving low latency connections. That's a posh way of saying it's very good for getting very fast data transfer. And the reason it does that is because it just ignores all the errors. So you might think that's a lousy system, but we do still use it quite a bit, in fact. So we then have this thing called IP, Internet Protocol. And as it says down here, it's the basis of all internet communication. And it's the it uses TCP and UDP are based on IP. You can kind of think as TCP is about getting packets from point A to point B. IP is about addressing within the network. So IP is the protocol that gives you the addresses. And as it says here, every computer gets a unique IP address. Now, we don't tend to use MAC addresses on computers, even though they've got them. We don't tend to use them, and the reason is because they're fixed, and therefore you can't change them. So if my computer goes wrong, what I can't do is, if my web servers say gone wrong, what I can't do is unplug it, wheel another one out of the cupboard, put it in place, plug it in, and then continue to use the same MAC address. Whereas if I've got the IP address, I can configure the IP address, and I can simply tell the new machine, yeah, it's got the same IP address as the old one, and then everything's lovely and everything works. So we tend to use IP addresses when we're talking between machines. We would tend to only use MAC addresses when we're setting things up. Then we've got this thing called DNS, which you know and you use a lot because this is the thing that turns your text addresses into number addresses. So the school website address there is 185.59.63.16, and we don't dish out IP addresses generally because they're too hard to remember. We give domain names instead. And what the domain name service does is it's simply a bunch. It's like, you can think of it as like a phone book. You throw a text address at the DNS server. The DNS server responds with the number, the IP address. And this is an example of UDP. When your machine wants to talk to a website, it will throw a request to at least 2 DNS servers. I think in school we've actually got 3 DNS servers running. So it will basically shout at all 3 at the same time, and one of those will then respond. So that's why it doesn't do the error checking. And the reason we only use UDP is because we want really fast translation of the address, because we do this a lot. Whenever one thing on the network, like say your PC talks to a printer, it needs to do a DNS lookup, and therefore it needs to be really, really fast. Now, IP breaks your packets up, puts them on the network. They take undetermined routes. They'll just route, the routers determine the routes, don't arrive in order, put them back together using TCP, and every machine has its own IP address. And then we've got these things called HTTP and HTTPS, Hypertext Transfer Protocol. And then you've got the secure version of it, which simply uses encryption. And this is the thing that transfers web pages. So that's why it's at the start of every web address. And as it says, it deals with the links between pages. So when you use HTTP, when you do an HTTP GET, in other words, you say I want a page, the HTTP protocol will examine the web page and identify the fact that, for example, that uses a thing called a style sheet, and therefore the web page on its own is no good. It needs the web page and the style sheet, or it will find the embedded images and that kind of stuff. FTP is file transfer protocol. It's all about sending a file from point A to point B. So it's based on TCP, and as it says, it's client server. So you've got 2 machines that talk to each other. One is broadcasting, that's the server, and the other one's receiving, that's the client. And the client can say to the server, I want this file, and then the server will send the file over. And as it says, it uses 2 data channels at the same time. One to control the transfer, because if you're transferring data too fast, one end may say, hold on, just wait on a minute, I need to catch up. And you can interactively run it. So you can run a thing called an FTP client. If you go into a command prompt on your PC, you may well be able to run FTP. And it will say, okay, what do you want to do? And you say, I want to open this FTP server. So you give it the address, type it in. And if that machine's got an FTP server running, it will then say, okay, what's your username, what's your password? And then once you've got that, you can then actually go in and look at files on the remote server. And then you can use a command called get to retrieve a file, or put to send one to that machine. And that's what's happening under the covers when you're using a web page. It's doing put and get requests, and it usually requires a user login. And a good security manager will basically stop FTP running on their network unless they absolutely need it, because it can be a security risk.